Hi, everybody. Artem works on log management at Qualys, and I work on web application vulnerability scanner engine. And we don't have any hardware hacking experience, so our talk is going to be focused on remote access to the cameras. So closer to Christmas time, I started receiving emails like from deal alerts that I can get a wireless IP camera for under $70. So I thought, yeah, why not? Let's do some research. And just searching in the Google for indoor wireless IP camera, like first 3 results are about false cam cameras. So I just got one. And while I was waiting for that camera to be delivered, I looked at Amazon's product page of the camera, and there are already interesting things listed, like it can stream data, it can email and FTP it to you, which means it probably stores the credentials, and it'd be interesting to see how they manage that. Plus, they refer to port forwarding as something simple to do. So we're really looking forward to get the camera and start playing with it. And so what the camera is. Well, we're going to talk about this particular model, FOSCAM FI8910W, which is MJPEG camera, which means they just stream JPEG files one after another over HTTP. But there are a lot of other vendors that probably use the same firmware, and we are sure they are using the same software that FOSCAM develops, or maybe some other company develops it for FOSCAM. We don't really know that, those details. But we know that a lot of MJPEG cameras that available are using the same software components. So yeah, it runs UC Linux, which is like embedded Linux kernel, very stripped, almost nothing on it, except the kernel itself. And this board support package is also available from the board vendor. So we were able to cross-compile and build our own executables. And we're going to use the terms that FOSCAM uses. They call every component of the system a firmware, but it's not really a firmware, it's just a binary file. But we're going to use the firmware word just to stick to their conventions. So, oops, sorry. So yeah, it basically consists of, there are 3 main components. System, which includes the kernel itself and the executable, which is one single executable, and all the CGI calls and embedded web server and probably drivers for the camera itself are packed in one binary file. Web UI, which is a file that contains the static HTML, JavaScript, and CSS, and some image files that are going to be served over HTTP, and settings file, which stores the camera settings and all your credentials and all configuration that would customize your camera. I'll just briefly go over what the files look like. So this system firmware is a custom binary file. It starts with a header, like 20 bytes or something. There are two different versions, but they are almost the same. And yeah, 4 bytes of magic number, and then sizes of 2 files, Linux bin and ROMFS image, and the files themselves. And yeah, you can see that Linux bin is zipped version of file, and ROMFS. The details are, you can mount this ROMFS on your Linux using the regular mount, and you can find details by this link, how to deal with ROMFS. It's read-only file system, there's nothing fancy. And web UI, it just looks like this. We don't work for Amazon, it's just Artem's apartment with Amazon box. We just received something, bigger camera maybe. And web UI is simple HTML and some helper JavaScript, which basically is for making CGI calls to the camera and to get some functionality out of it. Web UI is just a wrapper around CGI API. And yeah, all communication is in plain text. They use basic server authentication, and you can make a call to CGI either by providing this, how it called, authority part of the URL, like providing username and password separated with colon, or you can provide the credentials as a query string. Oh, it didn't fit on the slide, sorry. This, after video stream.cgi, question mark, there is username equals user and pwd equals password. They are both equal. And yeah, WebUI is also custom file with a header, and there's some kind of protection implemented, so-called checksum. And we experimentally figured out that this checksum is sum of all bytes starting offset C. Here's on the next slide. So yeah, that's a header, and then after header section starts the actual file names with file name sizes, then file size, then file itself. It's sort of a tar, if you wish. And settings section is a fixed sized 5 kilobytes file that directly mapped into the memory of the camera, and it's also very simple, like header with checksum, with the same algorithm for checksum, it's sum of all bytes starting offset C. It contains all the sensitive information, like all your credentials for the camera, your network settings, your Wi-Fi settings and credentials, email credentials, if you set up your camera to send out you the snapshots of what's happening, or if there's some movement detected. And surprisingly, for example, on their tutorial video, which most housewives, for example, are going to follow, they use Gmail as an example, and like, a lot of people provide Gmail credentials in the camera to send that information to their Gmail accounts. And settings file is the same, like third word is the checksum. So there's some, we're going to start, yeah, and after providing this brief overview, now you would ask how we get into that camera. They have usernames, they use basic server authentication. If you cannot sniff the traffic, how are you going to access it? So there are two major sort of vulnerabilities, or I don't know how to call it. Probably, yeah, it's vulnerability. So this authentication bypass was reported in mid-March by these two French guys, Arnaud and Frédéric. And there's some history behind this vulnerability. So initially, like 3-4 releases back, you would be able to access the alias of the memory by just requesting this first link, like camera URL and then /proc_kcore, and you get 16 megabytes? Yeah, 16 megabyte file dump, which is actually the camera memory, which contains everything. And then they patched it by not allowing any alphanumeric characters after, if there are 2 forward slashes. So bypass would be just level up. And then they fixed that too. And current version, the latest one, doesn't have that vulnerability, but some flavors of them, the third one, the Spanish one, we discovered, but I don't know, maybe it's the same thing, it's just a matter of which particular firmware you are playing with, because version could be the same, it ends with 48, but some 48s are vulnerable to this and some are not. But yeah, you can do the Spanish or some directory that exists on the camera, and you do 2 level up and then proc_kcore and you get the same dump. And also those guys found this privilege escalation URL where you could have a username, a user of the camera with operator role. There are 3 roles. It could be guest, operator, and administrator. And if you have somehow got access to the camera as an operator, you can dump the memory in, I think even in the latest firmware, through this URL. And kcore file. First of all, yeah, as I said, it maps that settings file twice. First at offset 3 megabytes and another one at offset 5 megabytes. And you have your old camera, for example, credentials right in that file. You can do strings on that file, you'll find everything, or you can use our tool that Artyom's gonna show later, that would automatically extract everything for you. It also contains some information on intranet. For example, I found my iPhone's IP and name in that file, plus I found my printer information in that file. Probably that camera has UPnP functionality too. They probably send some kind of broadcast messages and they store the replies. This path traversal is applicable to any camera. If you are targeting someone, you know he has the camera and you know he might open some email from you, this CSRF vulnerability could be useful. We filed a CVE for it a couple of days ago. I don't know, I'm sure a lot of people knew about this, but nobody documented it, so we did. So basically, for example, you can do a CSRF attack on any CGI call of the camera, because browser would cache the basic server authentication for you, and whoever would open this URL with already being authenticated is just going to make a request to the camera with these parameters. And this one, for example, would add a user CSRF with password CSRF with admin privileges. And every CGI call could be accessed like this. And so just to summarize, so if you want to get a camera, or besides buying one, you can get a camera by either in the wild, by going to Shodan, that's great search engine, and search for NetWave IP camera, and it would, Artyom would go deeper into this. And yeah, just vast majority of cameras would still have this path traversal vulnerability, or you can always do login brute force because they have no protection whatsoever, like no throttle downing the connection rate or nothing like that. So, and password and user fields are 12 bytes long, so it would be pretty easy to brute force. Or if it's a targeted attack, you do the CSRF or clickjacking because they don't do any anti-framing protection. No, yeah, nothing. Not through JavaScript, not through, what was the header? X-frame options, yeah. So yeah, from now on, we are assuming you somehow got access to the camera, so what's next? And Artyom would tell you.
So once you got access to the camera, so here are some things that you can do. So apart from the obvious things like grabbing the video stream or acquiring all the credentials which are stored in a camera, like email, FTP, it can store your ADSL password, your Wi-Fi password, and it's basically, as you have seen, it is like a pretty nice scanner of the intranet. So you can just dump the camera memory and see what other things are out there. So you can, in principle, think of this camera as just a small Linux box with, an ARM machine with very limited amount of memory and CPU, but it's a fully fledged Linux box. So you can, in principle, run arbitrary software on it, and you can think of something like a botnet bot, or an anonymizer proxy, or just a scanner for an intranet, or since it's the web server after all, you can use it to host your malware. And from another point of view, it's also, you can think of it as a box on the intranet, which is accessible from internet. So it can be like a platform for advancing your attack further into the network. And it also can be used as, again, as a platform to attack the browser of the victim, because you can always use that web server. And you can also use I will show later how you can modify the web interface of the camera. You can use it as, to put something like a beef there, like browser exploitation.
Persistent cross-site scripting.
Yeah, to host a browser exploitation framework and get a hook into victim's browser. So now let's pick some numbers, because, okay, if you have one camera or two, but in fact, what is interesting here that you have hundreds of thousands of these cameras out there. So just according to Shodan, there are about 100,000, Shodan knows about 100,000, so this is our findings, but I have heard some other people speaking about much bigger numbers. But anyway, there is at least about 100,000 cameras out there, and the number is growing. And the funny thing is that if you go to, for example, like 3 hours before I was to fly to Amsterdam, I bricked a camera that I had. So I had to run to a store to buy one. So when I went there, you find them in home security section. So they sell these devices as something, to secure your home, but in fact, you're just buying a big breach. But nevertheless, those are very popular. So the numbers are growing. And yeah, so if you want to find these cameras on Shodan, you just have to enter this NetWave IP camera in search, and this is the HTTP server header that the camera replies with. So this is how Shodan identifies those cameras. The other way to find cameras is the DDNS. So since this is a very consumer-oriented product, the camera vendors, what they do, they provide a DDNS service. So what happens is that each camera has a pre-assigned host name, and what happens is that whenever you hook the camera to the network, first thing it does, it dials back home saying that this is me, so that in their DNS server there is a record which associates this kind of hard-coded host name which your camera came from with your IP address. You can of course shut this off, and there are some vendors which implement this using not DNS but by using a web server. Like they have an Apache, so you go to their web server and then they send a 302 with the reply to you, with your actual IP address, but the principle, the idea is the same. So just out of curiosity, one lazy afternoon, what I did, yeah, and the format, again, for usability purposes, this host names, all the host names follow certain format depending on a vendor. So for example, for FOSCAM, it is 2 letters followed by 4 digits. So what I did, I just wrote a shell script which I just scanned the entire DNS namespace for this FOSCAM. So it turned out that there have been about 140,000 records with valid IPs. So because in fact they have, I think, because of some security consideration, they didn't want to allow creating new records in the DNS. So what they did, they just predefined all the records, but the records which have no value, they just put 127.0.0.1. So when I say valid, I mean all the IPs except for the local host. So I scanned the DNS and I found like 140,000 valid IPs. Out of those, at the point when I was doing scan, 41,000 actually responded to ping. And out of those, 7,200 had a web server running on port 80. Now, not all of these, of course, are cameras, because in fact, most of the cameras are behind NAT. So what you see in the DNS is the IP address of the router, which they use to get to the internet. But some of them are connected directly, and some of them have this port forwarding. So because one of the biggest problems with these cameras is that the way how vendors recommend to set them up is broken, is very bad. So that's why you have people just do the port forwarding on port 80 and expose their cameras to the internet. So out of those, there were actually 2,600 cameras, which were actually cameras which I was looking for. And I didn't scan any other port apart from 80. I just scanned only one vendor. So it would be pretty safe to assume that if you're really after it, you can really find in no time thousands of these cameras. So, right. Now, actually, we were supposed to give a demo, and that's why, like 3 hours before going to the airport, I was running to the shop to buy a camera. So I bought the camera, it was okay, brought them in, and then, we came here. So first thing we did, we wanted to, to make sure that everything works. So I went to speaker lounge, set everything up, hooked up the camera, and I successfully bricked it. So it was like Murphy's Law in action. But what happened is that actually, if you go to speaker lounge, they have this place where you actually connect your camera to the power, and it's very flaky. So what happened is that while I was updating the firmware, someone touched it, and the power went up and down. So bad luck. But we nevertheless, we couldn't, we knew that something will go wrong, so we made a screencast when we were at home. So I'm going to show you the screencast, and I hope you won't be very disappointed. So, what we're going to demonstrate here is several things. So first we're taking a vanilla camera. We actually were not demonstrating how to, we assume that we know the password, because getting the password is trivial. So you just have to dump the memory and read it from the predefined offset. So what we do afterwards, so we create a backdoor. So we create an admin user and then modify a web interface in a way that we poison it basically. So when the legitimate user goes to the web interface, she doesn't see anything. So the next thing we do, we add the hook, we inject the JavaScript to the victim's browser, and the idea is, so we can do several things there, and I will show. And the last thing is we modify the camera firmware. So what we do, we install a proxy server on the camera, and it's written in a way that if the legitimate user is trying to opening a connection to it, then it forwards traffic to the legitimate application. But otherwise, it is used as a proxy. And Sergey will talk about it in more detail. So here are the steps that need to be performed for poisoning the web user interface. Now, it could have been much simpler in a sense that, we could just replace the web interface with one version, but the thing is that our idea was that it doesn't make much sense just to put something random on a camera because the owner will notice very quickly and will take it down. So what we do here, we first try to figure out what is the version of the firmware that's running on the camera. So we find the same version, we modify it, so we unpack it, then we modify it, and we pack it back, we verify that the checksums match and everything, then we push it to the camera and clean up the logs. Now, these blue parts that you see here, this is actually, so we actually developed a small toolkit for doing this. So, for extracting and packing web UI, system firmware, and also settings. And also we just put a small script together which lets to perform all these steps, in one go as a single command. So I'm going to, oops. So I'm going to show you the screencast now. Is it a PDF? No. It will be funny if the screencast doesn't work. Okay, so the first thing that we do here is I think you just paused it.
Yeah. Okay.
Yeah, so we first show that, we have a camera, it has a user admin empty password. We log into it, we just show that everything works. It's just me and Sergey sitting there recording the webcast. So then we navigate to, so this is how the web UI looks. You have probably seen this. Oh no. So this is how the administrative part of the web UI looks like, and this is the list of users of the camera. So it's just vanilla camera, just out of the box, fresh. So it's only admin user with no password, empty. So what we're going to do, we're going to inject a new user in position 8. And this is the script that we run to poison the web UI. So as you can see, this writing's in green, so it figures out the version of web UI, then finds the matching version, verifies that it's correct, then unpacks it, puts our patches in place, packs everything back together, and pushes it back to the camera. Now, when it pushes back to the camera, as you can see, the camera becomes unresponsive because it needs some time to reboot and put the new web UI in place, and you see that nothing is going on. I'm hitting refresh, but there is no response from the camera. So I think I can. So yeah, I'll just forward. Yeah, so at this point, so I'm still waiting for the camera to come back, and I think it still has some 50 or 60. Right, so this is what we're waiting for. So it stopped responding to pings, and the moment it comes back, it means that the camera is up again, and we will go back to the web server. Okay, so it's back. Right, so here we log in with the new user that we just created. Instead of admin, it's Hack in the Box 2013 Amsterdam. And so you can see that it still works. And actually when it's booting, it just rotates around itself. And so we go to user section, and you see here that it's the same thing. It's just, this admin user, but the new user, which we just created, it's not here anymore. It's not displayed here because we poisoned the web user interface. And so the next thing that's going to be demonstrated here is, this is again just to demonstrate that nothing is broken, everything is working. So the next thing that we're going to demonstrate is injecting the JavaScript into the web UI. So what happens here is that first we're going to replace the video stream with the still image that we take on the fly. So now, yes, this is me struggling with Firefox icon. Yeah, and as you see the image is now, it's a static image. So a lot of people use these cameras, for example, for their garages. So, if you want to break into the garage, this is what you do. So this is the JavaScript that we inserted. Again, there was an alert, and now we brought everything back. Things are still operational. I think, yes, so I think this is it for this one. So the next demo, the next demo is, so what we're going to do, we're going to alter the firmware of the camera, not the web user interface. So again, here steps are very similar, that we need to find the right version, unpack it, push our changes in. The difference is that it's a bit more complicated because, as Sergey told, the firmware is the Linux kernel plus this read-only file system. So what we need to do, we need to mount this read-only file system. Since it's read-only, we cannot write to it, so we have to copy it over, add our changes, then generate the new image out of the directory structure that we have, and pack it back. And another complexity is that the thing that we're going to push to the camera, the executable, has to be cross-compiled so that it runs on a camera. And the actual thing, again, the things in blue are tools which were missing, and we wrote them, and the code is available. So
it's just
I'll let Sergey explain what we're actually pushing to the camera.
Yeah, first we wrote some echo server, then we wrote a proxy just to demonstrate, because you can compile anything on it.
Yeah.
It compiles any C code. We have problems with compiling threads, but it's solvable.
Because the Linux kernel is very old.
Is old, yeah. But yeah, proxies just acts as a reverse proxy. Is whoever connects to it doesn't know it's a proxy, and so just camera's web server would respond to the responses to the request to proxy. But if somebody knows that it's a proxy, the proxy server would act as a proxy server, normal proxy server. Like, for example, if it's a connect keyword in the beginning of the request, that means it tries to establish a tunnel to google.com port 443, and it just acts as a normal proxy.
So,
And point is that since the owner of the camera port forwarded or enabled only port 80, our script is downloading the firmware, changing the listening port for that embedded web server to, for example, 81, and our camera listens to port 80. So it still works, everything still works from outside of his intranet. And
as well as from inside, yeah.
Yeah, as well as from inside. So yeah.
So the next is again another screencast. So yeah, again it starts by demonstrating that everything works. Then we launch this script which does everything, which just automates all the steps that I just described. Yeah, as you can see, we're changing the original port on which camera listens. We're just bumping it up, and then I can just maybe. Yeah, so what we do here, we change the port and we find the right version of the firmware, we verify the integrity. So we extract it, then we push our binary to it, we regenerate the file system image, then regenerate the firmware image, and we push it to we're uploading it back to the camera. And once it's back, so actually what happens here is that we do this HTTP post, we get HTTP 200 OK back, but then still we have to wait for some time until the firmware is extracted and applied, and the camera is rebooted. So I think we can fast forward here a bit. So yeah, here. So yeah, again, you see that we're waiting for the camera to reboot. It's not responding to anything. So yeah. Now when it comes back, what we want to see, we still want to see that the videos, that it is still working, and that the video stream is still available on the same port. So here is just
the proxy starts
shortcut. So it's a shortcut URL to demonstrate the video stream, but the difference is that it's now the traffic is going through our proxy, and you see it's a normal browser, and we type in the URL of the proxy, and it still works. Now, what we do next, so what we do next here, we just enable a proxy. So we make our browser to use the camera. So you can see the IP of the camera, and port is port 80, just the same port that we just use the browser to connect to. Now we use this, we use camera as a proxy. And then what happens is, so we basically try to access Google. And I'll fast forward a bit, and it works. So we type search command, and and you get the results. The reason why you see these things here is that the camera is, so it has very weak CPU, and what happens is that browser normally opens lots of threads, and camera is it is having some hard time serving them all together, and our proxy is not written in the most optimal way. It's just to demonstrate the proof of concept. So this brings me back to our next slide. Yeah, so this is just one script which lets you do with just one command for injecting executable or poisoning web UI, or if you want to specifically inject proxy, just to do these extra steps of changing the port on which camera listens, it can do that too. And
yeah, that was the demo. Some other things to consider is how the camera responds to denial of service attacks. For example, I pointed the tool I wrote, that slow HTTP test, which actually a application layer denial of service attack simulator, and just to see, of course it's an embedded device and it's not going to handle too much connections, but yeah, it dies after 80 concurrent connections, which means it's for a bad guy, if he wants to disable camera functionality for a while, he can launch it, he can knock it down in, what is it, like 5-6 seconds, and keep the DOS condition for as much as he wants. So that's how camera. And plus, since camera doesn't log any unauthenticated requests, there are no traces even of your denial of service attack. So how to fix it? The newer and like more expensive, more advanced versions of cameras manufactured by that Foscam now, like starting last month, they support HTTPS connections at least, for example. But yeah, if you gonna stick with these cheaper versions of cameras, that MJPEG cameras that are under $70, I don't know. Ideally, I wouldn't expose it to the outside network at all, because I don't know. You can still make it to send you emails or dump everything to FTP on your local network and without exposing the camera. But if you have to, that's what we recommend. Just use some box in front of the camera, like firewall or IPS, which would run, for example, fail to ban, which would whitelist only your IP or IPs you know. Protect from brute force by throttling down connection rates, and you can also have a reverse proxy, and you have at least an HTTPS connection between the reverse proxy and the end user. And yeah, it would make sense to override response headers by not saying that you are NetWave IP camera, and so script kiddies won't play with your camera found on Shodan, maybe. Then summary is just for hackers, you just got another tool to play with the camera you own or somebody else owns. And for admins, I would start looking at the NetWave IP camera header, because I think there would be a lot of traffic coming from them, because if you can host a malware there and the IP of the camera is not compromised by Google Safe URL, whatever, or the Microsoft's that engine, you can host every piece of malware on different cameras, since there are hundreds of thousands of them. Yeah, just look for traffic from those cameras. And for regular users, just don't expose it. That would be the best thing to do for now. Or get more expensive camera, but who knows what other vulnerabilities are there. And we didn't do any hardware research, because first, we don't have any experience in hardware hacking, and second, there is the forum OpenIP Cam.
Yeah, actually we listed on the last slide, yeah, all the references.
And yeah, these are references. OpenIP Cam has a lot of very useful things, but you have to have a physical access to the camera and to the serial port. Yeah, there are several tools available as well, and CGI SDK is also available by Foscam. And that's pretty much it.
Thank you. Any questions from the floor? Yeah, okay.
Have you examined cameras that are more expensive than $70?
So we were just targeting cameras which are based on this firmware, and normally these are, you know, the low-end consumer. We know that the same vendors have more expensive versions, like outdoor cameras and things, you know, with more sophisticated web interfaces, etc. But we didn't look to any of those.
But how about the more famous brands like Axis and Sony?
Oh no, we didn't look into any other. So there are like. So this I don't know if like, for example, Sony or Panasonic, we don't know if they're using the same firmware from these guys or not. But I don't think it's going to be likely, no. So these are all like all Chinese companies. So.
And they're cloning, one company clones another from firmware from another, and boards are cloned. So that's why they are all vulnerable to the same things.
Thank you.
Any other questions on the floor? Okay. They will be around until the end of the conference. Feel free to approach them off stage as well. Thank you very much.
Thank you.